Hey, good morning, algebra geometry friends. So we're talking about algebra today. This is homework 2.5, talking about algebraic. Make sure we go put there algebraic proofs. And so this is the definitions and questions. Let's go ahead and get started. Jump right in. Definitions. And so what this lesson basically covers is it takes what you've learned in pre-algebra and algebra, very basic algebraic steps, and it begins to introduce you to the idea of proofs, where then you have to supply reasons. You have to supply mathematical justifications for why you can do those steps. So it can be a little challenging because maybe you're used to just solving equations a certain way, and you've never paused to think, well, wait, what is the reason, or why am I allowed to do that? This lesson is going to give you the vocabulary, the reasons to go with the algebra that you've already learned. And if you're a little shaky in your algebra, this can be a useful lesson because it will reinforce the proper way to solve equations. So our first definition is this addition, subtraction, multiplication, and division property of equality. And I always just call this is just the fancy words for some simple facts that have to do with all four operations: addition, subtraction, multiplication, and division. So for example, for addition, basically, if you have an idea where you have A equals B, the addition property of equality says that if I add C to both of these, then they are still equal. That if, actually, let me erase this or say it this way. If A equals B, then A plus C still equals B plus C. And this is just your algebra rule that if you add something to one side of an equation, you have to add it to the other side, because therefore you're not really changing it. We'll just write this one out and we'll go into detail with each one. But for example, if you have something like, 5 equals 5, and then I add the same number to that, 5 plus 2 is still equal to 5 plus 2. That's as long as you add something onto both sides, you're not really changing the fact that they're equal, because that would still be 7 equals 7. So that's what the addition property of equality is. And in algebra, you've learned that, again, if you add something to one side, you can just add it to the other, and you're not really changing the equation. Okay, subtraction, these are all just the same. You could write it over here. If A equals B, then A minus C is equal to B minus C. Same idea. If you subtract something from one side of the equation, then you can subtract it. Then you need to, if you don't want to change the equality, subtract it from both sides. Multiplication, same idea. If A equals B, then A times C is still equal to B times C. Again, algebra taught us if I multiply something by one side, then I just need to multiply both sides by it, and I haven't changed the equation. So then division, you think you've struck the pattern already. If A equals B, then A divided by C is equal to B divided by C, as long as C isn't equal to 0, but we'll pick up on that. Not too important at this point. Okay, so you have the addition in red, we have the subtraction in blue, and then multiplication. And again, that's just referring to algebra rules that you already knew, but now you have a name. They're called either the addition property of equality, subtraction property of equality, multiplication, or division property of equality. And you'll see in the examples of how you're going to use those. Whatever thou shalt do it to one side, thou shalt do to the other side. One of the primary commandments of algebra. Okay, transitive. Oh, did I do these out of order? No, we're fine. All right, so the transitive property says something like this, that if A equals B and B equals C, then A equals C. You might recognize this from the law of syllogism, basically saying A is the same as B and B is the same as C, so then you could just jump from A to C. So this is a lot like the law of syllogism, but it's called the transitive property, in that it transfers along B to connect A and C. At least that's how I think of it. Okay, and you'll see in math where we use that for an algebra. Symmetric property, this is a real simple one. You'd use this all the time, but don't think about it. But it's just mathematical sense that it says, let's see if I make sure I say it right. If A is equal to B, then B is equal to A. All right. So it's just reversing. But in math, we've already, it doesn't really matter. I can say, if you gave your final answer as 3 equals X, I couldn't mark it wrong and say, well, no, X equals 3. No, that's the exact same thing. It doesn't matter the order. We can read algebra left to right or right to left. That's what the symmetric property is saying. The reflexive property is even more interesting, and it's just simply the fact that A equals A. It's just a way of saying that something is equal to itself. And you'll see when we get into geometry proofs that how this comes in useful. But don't overthink it. It's reflexive. It's almost automatic. That something, it's kind of like I call it the no-duh property, that something is equal to itself. Substitution, this is a little similar to the transitive property. But that basically says that if A, oops, not equals. If A equals B, then B can be substituted anywhere for A. You're going to see right away where this is used, but whenever you quote unquote plug something in, whenever you plug it in, you're doing substitution. You're saying, oh, so if we have 3x, and then you say, okay, x equals 2, and so then you say, okay, so then 3 times 2, that's substitution, because you're basically saying x and 2 are the same, so wherever x is, I can substitute 2 for it. So whenever we plug it in, that's the substitution property. And then finally, distributive property. This is simply where if A times B plus C, then it's the same as multiplying that through to AB plus AC. So whenever you're solving a problem and you distribute through parentheses, you just call it the distributive property of equality. Okay. And finally, segment addition postulate. We actually already talked about this, but I just wanted to reinforce it because, even then, it all doubles as even the angle addition postulate. And this is just that the sum of two segments equals the combined segment. I'll draw this out. But what we're basically saying is if you have a segment here and you have segment A, B, and segment B, C, segment addition postulate simply says that if I add AB plus BC, then that equals the entire combined segment of AC. And you're going to see how when you solve an equation, this is a step you're doing it. You're including. And of course, that's the same for an angle. If I have, I won't write it out, but if you have angle ABC, that is the combination of ABD and DBC. Okay, I'll go ahead and write it out. Angle ABD plus angle DBC equals the combined angle of ABC. So that's what we mean by either the segment or the angle addition postulate. Okay, so let's look at some examples. And the last one in particular, where we'll see some of these things in action. So let's look at question number 1. In terms of better understanding these, number 1 asks us, which property is the obvious stating that something is itself? So sometimes you're like, that's so simple. When I see that A equals A or 3 equals 3 or something like that, that is simply just, it's reflexive. It's automatic. Think of your automatic reflexes. Reflexive property of equality. Alrighty. So number 2, which property is like looking in a mirror and seeing the same thing only backwards? All right. So that's in other words, A equals B then that's the same as B equals A, right? That's what we call, when you look in the mirror, I don't know how you want to remember it, but it's the symmetric property of equality. Alrighty, number 3, which property is like a bridge between two other equalities? Okay, so for example, we said A equals B, B equals C. So there's two different equalities, but we can bridge them because they have a common, they both are the same. You know, Joe is as tall as Sam, and Sam is as tall as Chris. Therefore, Joe is also as tall as Chris. That's what this one says. That's what we're referring to as like a bridge. The B provides a bridge between the two. We learned that's called the transitive property of equality. Okay, so just kind of a refresher through those 3 questions. And then number 4, here's an example. And this is an example where we have an algebra equation. We're going to solve it like we know how to, step by step. So sorry, you speedy algebra solvers, you got to slow down in this lesson and consider each step carefully. And then off to the right, we're going to write what the reasoning. Okay, so I'm going to start by solving this really slowly, and then we'll do the reasons. Okay, so first off, let's see. I'm going to start by, let's add the 30 to both sides. Okay, because that's going to cancel that. We want to get the p's alone. So that cancels out, and we get 2p. You're going to want to be real neat with this so you can clearly see each line. Negative 4p plus 36. Okay, so the next we're going to add this negative 4p, because if I subtract it, it would just get bigger. We want to eliminate it. Alrighty, so I can add 4p to both sides. That's going to cancel out. So nothing new, we're just using the algebra we know how to do. So 6p now equals 36. And the opposite of multiplying by 6 is dividing by 6. So let's divide both sides by 6. Because 6 divided by 6 is just 1p. So now we can see that p is equal to 6. All right, so there's your typical algebra. We could box that. That's our final answer. But that's not all. They want you, and it says, give a justification for each step. So let's go over here, and in blue, let's justify that. We're start learning something called a 2-column proof, where we divide our statements on the left with what we call our reasons on the right. So start with the first step. How did I know that 2p minus 30 equals negative 4p plus 6? Well, the first step, the only reason I knew that was because it was given to me. That's going to be one of your first steps. It was given. That was the given equation. They gave it to me. That was the starting point. That will always be your first reason. Okay, so then how did I get from that to 2p equals negative 4p plus 36? Well, I got that 36 by adding the 30 to both sides. I added the same number to both sides. If you remember our definitions, that's the addition property of equality. Now, go ahead and know how I abbreviate this, because you don't necessarily have to write it all out. The addition property of equality, because I got to the next step by adding something to both sides. Okay. And then, okay, how did I get from 2p equals negative 4p plus 36 to the 6p plus 36? Equals 36. Well, I added again. I just added 4 p's to both sides. So that's just the exact same reason. Praise the Lord. Addition property of equality. All right. If I had subtracted, I could call that the subtraction property of equality, but I haven't subtracted. But it's the same idea. Now, how did I get from 6p equals 36 to p equals 6? What did I do there in the red? I divided. All right, so there it is. I used the division property of equality by dividing both sides of an equation by the same number. I looked at it as a new way, which is p equals 6. So start with the given, and then just watch what you do. And if you add, it's the addition property. If you subtract, it's the subtraction property, division, multiplication. If you have to distribute, then that's the distributive property of equality. And so again, it's almost seems kind of tedious, but it's one, a good practice for your algebra. 2, it's getting you used to every time you solve something, you have to explain it. And you solve it, you have to explain it, because we're going to be moving on to geometric proofs in the next couple chapters. And so that's what this is building, your ability to say, I know this to be true because I did this, this, and this, and here were the reasons that I did it. All right, check out the next video on the exercises if you'd still like to see a couple more of these things in action being solved. All right, good luck.